Okay, alkali metals. Okay, very reactive, stored in oil, and all the alkali metals are very reactive, meaning that they will lose the electrons quite easily to become positive ion. So alkali metals are reducing agent. Okay, because reducing agent undergoes oxidation process, and losing electron is an oxidation process. Okay. Now, compound of alkali metals. So alkali metals is very reactive, so they can combine very easily with other substance to form a compound. And the compound that is formed is an ionic compound, because alkali metal is a metal obviously, and metal reacts with non-metal to form ionic compound. Okay, ionic compound is metal and non-metal, and most of the ionic compounds are soluble. So example of ionic compound would be, for example, sodium carbonate, potassium carbonate. There are many others like sodium chloride, potassium chloride, calcium chloride. All these are actually examples of ionic compounds. Okay, so in general, group 1, 2, 3 elements tend to lose electrons because group 1, 2, 3, group 1, group 2, and group 3 elements have 1, 2, and 3 valence electrons respectively. So they tend to lose the electrons to form positive ions. Okay, and the charge of the ions is the same with the group number. So group 1 elements will become ions with charge of 1 positive, and group 2 elements, when they lose the valence electron, they'll become ions of charge 2 plus. Okay, and likewise for group 3, there'll be 3 plus. Okay, so example here is a group 1 element, lithium, loses 1 electron to become Li1 plus or Li plus. Group 4 and group 5 tend to share electrons to form covalent bonds. Okay, and then they have varying oxidation states. Maximum oxidation state is the same with the group number, and this is the example here. Okay, so same thing for groups 6 and group 7. Group 6 and group 7, meaning that they have 6 and 7 valence electron respectively, so they tend to gain electrons to form a negative ions. Example be iodine. So that is the groups in general. Now, just now we study more in depth group 1 elements or the alkali metals. So now is group 7 elements, and also known as the halogens. Okay, group 7 elements are also known as halogens. Now, one thing that you need to take note of for these group 7 elements would be they exist as diatomic molecules. Okay, group 1 elements or the alkali metals, they can just exist as atom. For example, sodium, just Na. There is no such thing as Na2. Okay, same thing for potassium, K. There is no such thing as K2. But for halogens, they must be in diatomic. They are in molecular form. Okay, so they exist as diatomic molecules. An example would be chlorine. Okay, so there is no such thing as Cl, only Cl2, and fluorine also, there is no such thing as F, only F2. And likewise for Br2, I2, and At2. That is the meaning of diatomic, 2 atoms together in pair. Now the physical properties of halogens are this one. There are a lot of things to remember here. The physical properties: low melting and boiling point. Okay, that means they boil or melt very easily. They exist in 3 states of matter. Fluorine is gas, chlorine is gas, liquid, solid, and then of course for At, for acetylene, it is solid. So for the states of matter, it is gas, gas, liquid, solid, solid. You have to remember that. How about the color? Now color, fluorine is pale yellow, chlorine is greenish yellow, bromine's reddish brown, iodine's purplish black, acetylene, At, is black. So it is pale yellow, greenish yellow, reddish brown, purplish black and black. Now as you go down the group, what happened to the melting point? When you go down the group, the melting point increases. Now melting point and boiling point, they are closely related to each other, meaning that when melting point increases, boiling point will increase as well. So for this halogen, as you go down the group, because as you go down, the states of matter changes from gas to liquid to solid, and obviously the melting or the boiling point must increase as well, because solid has higher boiling point than gases or liquid. Okay, so as you go down the group, melting point increases, boiling point increases, and the color becomes more intense, because the color, as you compare the color for fluorine is pale yellow, right? And then acidity is black. So as you go down, the color actually becomes darker or more intense. Intense and dark mean the same thing. And elements change from gas to liquid. This one I mentioned it just now. Okay, now how about chemical properties? Halogens are very reactive non-metals. Why? Because they have 7 valence electron. They're only short of 1 electron. So they'll try their very best to get that 1 electron that they are missing. That is why they are very reactive. And halogen plus metal, you get something called halide. Halide and the halogen salt are the same thing. Okay, so an example of halide would be sodium chloride. So sodium chloride is an example of halide or halogen salt. Okay, so basically over here it says that the metal will react with halogen. Now how about the reactivity? The reactivity, as you go down the group, atomic size increases, right? As you go down the group, the atomic size must increase. When the atomic size increase, it is harder to accept the electron. Now let's go back to our atomic structure. So if you look at fluorine, fluorine is in period 2. So fluorine, when you look at the electronic structure, so fluorine would be like this, 2 valence electron, 2 electrons on the first shell, and then the second shell it would have 1, 2, 3, 4, 5, 6, 7. So fluorine would be like this. And then chlorine is in the 3rd period, so it would have 3 electron shells. Okay, and then 1, 2, 3, 4, 5, 6, 7. So chlorine would be like that. Now both fluorine and chlorine has 7 valence electron, meaning that it would try to attract another electron to become 8 valence electron, whereby it is stable. But is it easier for chlorine to attract this extra electron, or is it easier for fluorine to attract this extra electron? It is easier for fluorine to attract this extra electron because it is closer. This valence shell is closer to the nucleus, and thus the attraction forces between the nucleus and this extra electron will be stronger. So it is easier for fluorine to attract this valence electron and then put it here, as compared to chlorine to accept this electron and put it here, because of the sheer distance from the nucleus. Okay, so meaning that your fluorine would be more reactive than chlorine. Alright, so as you go down the group, atomic size increases and it is harder to accept an electron. So it is harder for chlorine to accept this electron because of the weaker attraction from the nucleus. So reactivity decreases. Now accept electrons. Halogen will accept electrons, right? So halogens are strong oxidizing agent, because oxidizing agent undergoes reduction, and reduction is the acceptance of electrons or the gaining of electrons. Now how about the displacement reaction? Now what is this displacement reaction? A more reactive halogen will displace a less reactive halogen from its halide solution. Now let's take a look at this example here. Basically, displacement, the word displacement means replace or take the place of. Now let's look at this. This is the reaction between bromine and potassium iodide, Ki, potassium iodide. So bromine and potassium iodide. So you know that, take note that bromine and iodine, they are halogens. Which one is more reactive? Just now we said that as you go down the group, the reactivity decreases. So lower it is, less reactive it is. So if we compare bromine and iodine, which one is lower? Iodine is lower. So iodine is less reactive than bromine. So bromine is more reactive. So when bromine is more reactive than iodine, what happens is that this bromine will displace iodine from potassium iodide. When bromine displaces iodine, iodine will be replaced by bromine, or bromine will replace iodine. Okay, bromine replaces iodine. No, one more time. Bromine displaces iodine means that bromine will replace the iodine in the potassium bromide. In the potassium, so it will become potassium bromide, and then iodine would be by itself. Okay, in other words, bromine actually kick iodine out because bromine is more reactive, so it will kick iodine out, and iodine will be left alone. And what is with potassium now is the bromine. Okay. So this bromine we know is reddish brown. This Ki is colorless. So the color change would be from colorless to brown color. The color change for this reaction. Your potassium iodide would change color from colorless to brown. Okay. Now from this reaction we can see that it is an example of redox reaction because both oxidation and reduction take place. What is being oxidized is iodine. Because iodine, the oxidation state changes from -1 to 0. So there is an increase in the oxidation state. Whereas for bromine, the oxidation state changes from 0 to -1. So there is a reduction, or there is a decrease in oxidation state, meaning that it is a reduction. So displacement reaction. Displacement reaction is an example of redox reaction. Both oxidation and reduction takes place together in the same chemical reaction. So in summary, this is in summary for halogen, the trend in halogen. As you go down the group, melting point increases, boiling point increases, color become more intense or darker. Elements change from gas to solid. You need to know which one is gas, which one is solid, which one is liquid, and the reactivity decreases. So this is the trend of halogen in general. Now let's look at the last group, which is group 8 or group 0. So group 8 or group 0 are also known as noble gases or inert gases or rare gases. One thing to take note is that they are monatomic. Monatomic is from the word monoatomic. Mono means one. Okay, M-O-N-O, M-O-N-O, mono. Mono means one. Atomic means atom. So one atom. Okay, that means they are all gases. They are all of them are gases, and all of them exist in one atom. So there is no such thing as He2 or Ne2 or Ar2 or Kr2. It's all one. Most of the gases, they exist in molecular form, like oxygen O2, hydrogen H2. But for this group 8 or group 0 noble gases, all of them are monatomic, one atom only. So they're very special in that sense. Now as you go down the group, now this trend here is the same with the trend of halogen because they are just next to each other, they are neighbors. Therefore, as you go down the group, melting point increases, boiling point increases, same with halogen. Okay, let's look at the chemical properties. Now there isn't much chemical properties because all of them are very unreactive elements. Why? Because they have full outer electron shell, meaning that their valence electron shell are fully filled. Okay, they have no tendency to lose, gain, or share electrons. So helium, for example, helium, it has 2 valence electrons. All other gases have 8 valence electrons. That means their outer electron shell is fully filled. And the physical properties, similar to halogen, low boiling point or low melting point, because all of them are gases. All gases have low boiling point, meaning that they are very easily boiled. As you go down the group, melting point increases, boiling point increases, and they are all colorless gases at room temperature and pressure, and they are all insoluble in water. So that would sum up group 8 or group 0, the inert gases. And these are examples of the usage or applications of the inert gases. Neon, they are usually used in the advertisement signboard. Okay, for example, if you go to Las Vegas, there are a lot of signboards, colorful signboards at night, and inside the signboards are neon, filled with neon gas. Helium would be used in balloon, and argon would be used to fill the light bulbs. And of course, this one would be the color of the halogens. You can get these pictures from the textbook. Okay, chlorine is greenish yellow, bromine is reddish brown, and iodine is purplish black. Purplish black means it is black color with a little bit of purple.